Have you ever wondered how we get pure metals like iron, copper, or aluminum from rocks found in the earth? These rocks, called ores, contain both useful and metal compounds and unwanted impurities called gangue. To extract pure metal, the first step is concentration of the ore, separating the gangue from the ore. Let's explore some interesting methods used to do this. Some ores are heavier than impurities mixed with them. Such ores can be separated using the gravitational method, where heavier particles settle down and lighter gangue gets washed away. Two common processes use this principle: the Wilfley table method and the hydraulic separation method. Let's look at Wilfley table method. In Wilfley table method, a vibrating table is used. The table is fitted with wooden strips called riffles and kept slightly inclined. Powdered ore and a stream of water are released from the top. As the table vibrates, lighter gangue particles are carried away with the water, while the heavier ore particles, rich in minerals, get trapped between the riffles. These simple yet clever methods help separate heavy ore from light impurities using gravity and water. The hydraulic separation method works on the same principle of gravity. Here, finely ground ore is mixed with water in a tapered tank. A powerful jet of water is sent from below. Since the gangue particles are lighter, they flow out with the water from the top outlet. The heavier ore particles settle down at the bottom and are collected separately. This method separates particles of the same size but different weights, a perfect example of how gravity does the work. Some ores or their impurities have magnetic properties. This difference is used in the magnetic separation method. The machine has two rollers, one magnetic and one non-magnetic, connected by a moving conveyor belt. Powdered ore is poured into the belt near the non-magnetic roller. As it moves, magnetic particles stick to the magnetic roller and fall into one collector. Meanwhile, the non-magnetic particles continue and fall into another collector. This way, the ore is neatly separated into two parts based on magnetism. The froth floatation method is used for sulphide ores like zinc blende and copper pyrite. This method uses the difference between two opposite properties: hydrophobic, that is water repelling, and hydrophilic, water attracting. Sulphide ore particles are hydrophobic. They mix better with oil, while the gangue is hydrophilic and stays in water. In this process, finely ground ore is added to a tank with water and pine oil. Air is blown into the tank using agitator, forming bubbles. The hydrophobic ore particles attach to these bubbles and float at the top as froth, while the gangue sinks to the bottom and is collected. The froth, rich in metal sulphide, is then collected, giving us the concentrated ore. That's why this process is called the froth floatation method. Another important method is leaching, used for ores like bauxite, gold, and silver. Here, the powdered ore is soaked in a chemical solution for a long time. The ore dissolves due to a specific chemical reaction while the gangue does not. For example, in bauxite, the ammonia dissolves in aqueous sodium hydroxide or sodium carbonate, leaving the impurities behind. This method helps obtain a highly concentrated ore solution that can be later used to extract the pure metal. So now we have seen how ores are concentrated using different methods. Each method uses a unique principle of science: gravity, magnetism, solubility, and chemical reaction to separate useful metal from their impurities. Now that you know how ores are concentrated, can you think of which method would work best for iron ore? Yeah, I am leaving you with this question.